But yeah, so the topic is, so about 5 years ago, I actually said in a talk here that I will never write Java for fun because I'll never have time for that. And this entire talk is an apology for that statement because I was lying to you and that was wrong and I apologize for that. So yeah, so I'm a software engineer in New York and there's nothing else interesting about me really. So you can talk to me at lunch and I'll ramble about stuff, but none of it's interesting. So Java. If you're at this conference, you probably have an opinion of Java, and very likely it's not a very positive opinion of Java because what they taught you at school is wrong and horrible, and you should write your universities and yell at them and tell them I told you to do so. Why does Java get hate? The thing that turned me off initially from Java, correctly so, is that Java is verbose and wordy. You end up, so I used to work at Apple and I worked in the iTunes repo. And for perspective, iTunes had 60,000 folders for the repo. That's just the Java, that's just the backend. That's not counting the GUI that no one likes. It's the backend with 60,000 folders. I didn't even dare look at how many files were in there. That would hurt me too much. So, and Java also, historically, the way that it is taught, encourages really horrible concurrency that's incorrect, and then you get woken up at 4 in the morning to fix some broken code at Apple. I'm not bitter, but, and the Java Enterprise Edition, if anyone here worked on Java Enterprise Edition, don't talk to me because I won't be nice to you. I've spent the last 12 years of my life swearing vengeance on anyone who worked on Java Enterprise Edition, which is why I have not looked up who worked on it. So, and Java programmers are actually the worst part of Java. So Java programmers are annoying because they're really smart. I'm not challenging anyone's intelligence because they'd hurt me. The issue with Java programmers is they're frustratingly unambitious. They learned something in school 20 years ago, and I guess that was the perfect time to stop learning because there's nothing has been done in the last 20 years apparently. So so one issue with Java is that the I/O is blocking by default. And if you work in distributed systems and concurrent programming, everyone here probably has been on Hacker News and seen all the posts about Node.js, and we all pretend to like it. So but Java has blocking I/O by default, which is easy and it's predictable. It's predictably slow. So. And the synchronize keyword needs to be outlawed, and I can help them fix that. The synchronize keyword is horrible, and it was built wrong, and it encourages bad design, so don't use it. And the core design of Java, again, what they teach you in school at least, is that you need to mutate everything. You keep this little encapsulated state that is mutated by default, which again breaks concurrency because if you have 2 threads mutating the same state, it doesn't work correctly, and then you get paged at 4 in the morning because you got to fix iTunes crappy code. And so synchronize is evil. This is the classic deadlock example. This is not, everyone here has probably implemented this and also fixed this at some point. But synchronize, do 2 things. Thread A depends on thread B, and then they break each other. So when I learned this in school, back when I was a Wii tot, they taught me these UML diagrams, and there's a reason they always use shapes and animals because that's the only thing that applies to. It doesn't apply to anything else. This is not how computers actually work, at least my limited understanding of it. This is horrible. I didn't even like making this diagram for this talk, and I apologize for that to you. If I give anyone PTSD, you can come yell at me. But the animal hierarchy and dog and poodle and all that fun stuff. So everyone hates this, and they should because all of you are smart people, so I can say this confidently. If anyone else likes this, you have my permission to go smack them. So story time for me, because I'm fundamentally a storyteller. I dropped out of college in 2012, and when you drop out of college, if you go to Oxford or Harvard and you go to these fancy schools, you get to choose your jobs. You get a bunch of companies trying to get you to work for them. When you're a dropout, you don't. You don't get to choose anything. You apply to 10,000 places and one reaches out to you. So that's what I did. And the first job I got was doing Cold Fusion. If you guys haven't done Cold Fusion, your life is better than mine. So So Cold Fusion was this is this horrible language made by very smart people who are told to make things work in the enterprise world, which means wrong. And so so the Cold Fusion is like this abomination of like this quasi HTML language with like an XML thing with tags that has the advantage of going very slow and you can't read it. So that's pretty cool. And so I hated Cold Fusion, but then the worst part of my day when I did Cold Fusion was I would occasionally have to drop into the Java core for it, which would be this ugly, horrible mess. And then I have to write like some class, well, I have to read someone else's code for the class interface that they did wrong with the inheritance model that they were taught. And so I'd have to, so I have this opinion that, and this has been like a perennial thing my entire career, that every time I have to touch Java, I would hate it. It'd be the worst part of my day because Java was, the people who wrote the Java code didn't know what they were doing, and then it would be, so I'd sit there and spend 2 hours fixing some concurrency bug, swearing, inventing new swear words in the process, and it was horrible. So in Cold Fusion, you can blame for that. Because once you start, like your first job kind of defines the rest of your career, at least it did for me. So so I'm sitting here, I've been complaining about Java for the last, 10 minutes or so, and so why would we want to use it? It's why not just avoid it? Well, there's just a ton of tested libraries for Java that are all, not all, a lot of them are very good. They got a ton of funding thrown at them. They are pretty fast and well vetted, and so you got like Kafka Streams, Akka, Vert.x, and all these great libraries, and so you can mooch off the corporate funding thrown at it, and you utilize that. This isn't a big selling point for Java anymore because if you remember the 90s write once, run anywhere. That's not really advertised anymore, but it's still relevant because I suspect about half the people here are running Macs with like an M1 chip or something like that. But you're probably still deploying stuff to a server running an AMD chip or Intel or something else. So being able to have the exact same binary on both, it's still an advantage. It's not as big as it was. It's not running on like, I have a little ring that runs Java. I bought it on eBay a couple years ago because it was kind of fun. Then it had the little Java coffee cup on there, and so that was kind of fun. I've never used it, but and also, sort of tangential to the library thing, there's actually a lot of really great tooling around Java. IntelliJ is, it's a little, everyone kind of loves to hate on IntelliJ, but it's actually pretty good software, and it's free, at least the community edition. And so, there's lots of, profiling. JMH is a really good like microbenchmarking tool that kind of susses out edge cases for you, and there's lots of great stuff. The tooling around the Java language is actually very good, and most of it's free, so that's that appeals to me. And actually Java, again, I've been complaining about it for the last 10 minutes, but it actually can be very fast. It typically will beat, if you look at like, the tech and power benchmarks, Java usually is in like the top 10 fastest things in most stuff. So while it's often written slowly by people I don't get along with, it actually can be extremely fast when used correctly. So, so why not Kotlin or Clojure? Well, you should use Clojure if you can. Kotlin's fine. I never understood the point of Kotlin because it never seemed sufficiently better than Java. It kind of just seemed like Java++. But you should use Clojure if you can. But but Java is inescapable because whether or not it should be written in a good language, most companies have tens of thousands to tens of millions of lines of Java lingering around there, and get on my little communist soapbox here, but most companies, instead of spending $100,000 to rewrite a code base, they'll spend $10 million to maintain it because all companies know how to do is spend money. They don't know how to do anything else. So, whether or not they should, you're not going to win the arguments of we should use Clojure in most places. Sometimes, if you can, let me know. I'll work there. But you're probably not going to win the argument to use a good language if there already exists 100 million lines of Java just lingering around there because companies will spend infinite money to maintain a crappy code base. I mean, how much COBOL is still in the world? It's and so most of us are stuck in this. Not most. A lot of us are stuck in this hell. This is just life now. We justify it in our sleep and we just move on. But so in 2024, I took a job at a company called Schrodinger. And it was full Java. It wasn't like I had escape hatches to go write things in Clojure like I did at Apple. This was all Java. That was sold to me in the beginning. I don't blame them. They were young. They didn't know better. And so, when I tried to tell them to use Clojure, they decidedly did not care. So I complained a lot, and that was a battle that I lost. So eventually I realized that at least we were running modern Java, which is a lot, that's a big ask for a lot of companies, but we were running Java 21. So I was like, okay, well, if I can't use the features, the language I actually want to use, at least I can try to use all the modern features in there so I can annoy my coworkers as much as possible. And actually, surprisingly, and this was the thing that astonished me, I actually had fun. I actually enjoyed it. No one else was more surprised than me on that. I actually really thought I actually had a lot of fun writing it. So what changed? Well, since Java 8 and Java 11, there's been actually this push in the Java JVM ecosystem to support functional paradigms. And so the syntax has been updated to have like lambdas, and there's like the streaming systems instead of for loops. And it's actually been kind of pushing away from an imperative design into a functional design. So correct. And some Java programmers have finally kind of joined the 21st century and started to use non-blocking I/O. It's great. It's a wonderful world we live in. And actually now they've, in the latest Java stuff, they've actually really upped their concurrency game to where, again, it's actually fun. I actually enjoy it. So one of the things, I mean, most people here have probably seen this. So this is obviously a pretty typical for loop in Java. Everyone's probably written this 100,000 times. And this is the same for loop, but written in the streaming API. One thing people don't seem to know, there's no cost to this. This runs at the same speed. So that would surprise me. I did some JMH benchmarks to see if that was true, because someone told me that, and it's like, nah, it's not true. And no, it was. These run up within like 5% of each other, plus minus. So there's no cost to this. I guess the second gets translated to the first or vice versa. But this is cool, because that means you can use correct functional programming and not get yelled at by the corporation. So something that Java 8 introduced was default implementations for interfaces. So instead of these class hierarchies that I complained about, you actually get this nice little, not quite a Scala trait, but at least kind of trait-ish. And you can see I ran out of space on the side there. But so it gets something kind of adjacent to a trait, which is, I think, correctly that is much better than horrible class hierarchies. This is not new. This has been since like Java 3. But I mentioned this not because it's new, but because none of my coworkers knew what this was. It's blocking queues, and blocking queues are a queue that is blocking. What a clever name! But they are thread safe, and you can use them to do some like nice producer-consumer patterns. So they're in a hand-wavy way, kind of like channels in Go or Clojure. Not quite as versatile, but still useful. And there's a couple of them out there. There's the array blocking queue, which is probably the fastest, but it takes static memory versus links, which is typically it takes less memory because it's not full. And there's a few others. There's concurrent queue and stuff, which is I have issues with, but that's beyond the scope here. You can this is actually truncated. I ran out of room on the slide. There's supposed to be exception stuff around that, but I didn't have enough room for that. But basically, there's just, thread A puts data into a queue, thread B takes it out of the queue. That works as you think it works. And so there's no surprises there. So the thing that got me most excited about Java 21 is virtual threads. Now, if people here have written Go, one nice thing about the Go routines in Go is that they're built correctly. And by correctly, I mean they work how you think they work. There's not any foot guns on that. Go routines kind of do what they're in a hand-wavy way, roughly sort of preemptive. So you can just spin up millions of them, and they properly park I/O, so you're not constantly hogging up the loop. And virtual threads do the same thing. You can have blocking code in there. Mix and match blocking code to your heart's content. Just have fun doing it. And it's and Java's smart enough now to where it'll see a blocking I/O call and park the thread and then move on to the next one. So it's thread pulled behind the scenes, but you can just keep spinning up threads, millions of them. So they're extremely lightweight. You can spin up hundreds of thousands, and you can just use those without any guilt. beyond having the guilt from using Java to begin with. And you can just keep, writing them. And just to prove my point, because, I don't want you to take anything I say for granted. Let's see if I can do this backwards here. So you can see I'm spinning up 1 million virtual threads here. I'm doing some blocking I/O in the form of a sleep command. So that's just, and just to make sure I'm not lying to you, I'm using a countdown latch here. So this won't get to this print message unless the countdown latch is satisfied. So, let's hope I'm not lying to you. Let's see. Let's see if this works here. So it's going to take about 5 seconds. I can ramble for 5 seconds. That's what I'm doing now. And if in about 2 seconds, it should pop up. Yep. So thread's done. So that was 1 million threads. And you can see my laptop has 64 gigs of memory. So, it's not too bad, but this was a reasonable amount of memory in the process there. It didn't, if you're trying to spinning up 1 million, like regular threads in Java or 1 million P threads, good luck. And I've tested that up to like 2.5 million, and that still worked, but it was, then my computer got really hot, so I just figured it's 1 million's enough to show my point here. Let's see if I can remember how to get events into presenting mode. So the nice thing is that this is a drop-in replacement. So it uses the same interface as the regular thread thing. So for the most part, you can just change these into using the virtual thread, and your code really doesn't have to change. You just kind of just change the allocation to a virtual thread instead of a new thread. So instead of, having to rewrite everything using Akka or something, you can just, new virtual thread instead of new thread. Before virtual threads, you might be wondering, again, I ran out of room here. You had the thread pool executors, and they kind of did the same thing, but that's kind of what I'm getting at, is that they kind of are done wrong. Because thread pool executors they're great for certain things, but an issue with them is if you have blocking I/O, thread pool executors usually have a size, like in this case it's a size 4. If you have some sort of slow blocking I/O, like you say you're downloading an HTTP file that's like a gig large, that's occupying the entire thread for the entire download. So your thread pool basically goes from 4 to 3 in that case there. So bad. It doesn't work as expected. However, so now, if you already have a bunch of code using the executors, you just change it to new virtual thread thing there. So it's a drop-in replacement. The interface is otherwise the same. So so it actually works as you want it to work, not as you hoped it, not as it actually is. One thing that's actually been around since Java 15, I didn't complain about this earlier, is the garbage collector in Java was irritating to use because Java's garbage collector has, in some ways, in pretty much the last 15 years, has been a miracle of modern engineering, but it optimized for throughput instead of, so that's, for some stuff like Kafka, that's great. That throughput's, nothing against throughput. Throughput's great. But the issue is that if you say you're making like a chat room or something like that, what can happen is that you get these long pauses between messages because the GC decided to invoke, and that's no fun. So ZGC is actually great because it has low latency. Typically, you're talking like sub-milliseconds pause times on there. The max I've ever gotten it to do is 15 milliseconds ever. Like I was writing some contrived code to try to maximize the latency. I got 15 milliseconds. Usually it's never more than 10. It's usually never more than like a millisecond. So if you're writing like say a chat bot or something like that, or something that needs high responsivity and at the cost of throughput, ZGC is built into Java since Java 15. So you should use it. Well, if your project allows it. And it's configurable. It's not like you're not forced to accept that dogma. Not yet, at least. So another thing is that Java 21 finally got records. Just kind of snuck it in there. People didn't cheer like they should. So you don't have to have like a dedicated file to do it. You don't have like 50 lines to play with on there, and they can be pattern matched, which we'll get to in a bit. So before records, I didn't bother trying to truncate this to fit in there because this is what you had to write. This is what I'm trying to express. It's a visual metaphor for the pain I suffered writing this kind of code. So versus, let's go back. Let's see if I can get this to work. So versus now, if we go into IntelliJ, we can go into records. Isn't that nice? Look at that. That's it. That's the record. You don't have to do anything. And you get access to the same fields. These are immutable by default. So not by default, by only. So these are immutable, and you can just use them, and you can allocate them to your heart's content. There's still classes and stuff, so you can still pass them into places where you need to. You can't mutate them though, but yeah, and that's so much nicer. I refuse to accept that that's not nicer. So let's go get this working here. Let's go back to presenting. So sealed interfaces came about in Java 21, and they're roughly algebraic data types. You can recursively define them too. So you effectively can have interfaces that restrict how many sub implementations you get from it there, and they can be pattern matched. Again, we'll get to that in a moment. And let's go back to IntelliJ. I should have brought a monitor with me. I didn't think about doing that until right now. So we go to sealed interfaces, and these, you can have an example here where you have an interface of character, and I only want people to implement monster in player. So I do that, and the player has, you can read. You don't need me to read this to you. But these work as expected, and you can pattern match on them, which again we'll get to in a moment with more detail. But yeah, you can just pattern match on these, and you get this nice little sealed interface. So it's roughly analogous to a algebraic data type in Haskell or something. And go back to, I'm getting pretty good at finding this now. So before sealed interfaces, you didn't really have you didn't really have an equivalent before sealed interfaces. You just kind of had the trust that the implementations did it and pray. So this is roughly equivalent, but not really. It's not actually equivalent. It's actually worse. So now, pattern matching. This is like the one thing I was able to convince my coworkers was actually worth it, because pattern matching is great and wonderful, and this should be in every language by law. And so you can do this inside an if statement or a switch statement. And so before pattern matching, you kind of had this disgusting, reflection-y instance of blah, nah. We're all above this. So if we go back to my code here. So you can see here, I just wrote a little thing. So pattern matching, so you can see this actually will bind the record for the user I made. So this is the username and email, and I can use that. And just so you believe me, you can see it actually did unpack it correctly. So that's great. That's what we want. And you can also do this with switch cases, and they work how you think they work. I didn't make a slide for this. These are actually expressions now too. You could actually do something like, this will actually not work, but you can do like var result. See, typing backwards is harder than it looks. You can do that. You can, so you can actually, these are expressions now. I forgot to make a slide for that, so now I'm telling you. So don't sue me. It's, so yeah, and go back to, So Java NIO, this is not new. This has been around for 20 years. And no one told the Java community that, apparently, because Java NIO is great. It is wonderful. Every complaint I have about Java IO, I guess the Java engineering team agreed with me, because they fixed it. It's effectively a thin layer around ePOL or Mac OS, which uses like KQ, I think. So they're nice. They give you a nice blocking and non-blocking IO to play with. It's completely underutilized. Just for perspective, though, this was sort of one of those things like finding out Santa Claus isn't real. Sorry if you didn't know that. If we go down to NIO, this is sort of in a hand-wavy way, a re-implementation of Node.js. So I don't need to read this to you, but basically it's sort of a task queuing system like Node.js. This is done in about 100 lines, and if you run this, we get the same kind of Node.js style concurrency with scheduling. This is single threaded. And so it killed the magic for me, because Node.js seemed so cool when I first learned it. But now I can build it in 100 lines. So it's like finding out my parents are the tooth fairy. They're for me. They're not your tooth fairy. So okay. So Vert.x, this is another thing I discovered. I didn't discover. I didn't invent it. I just use it. But this is kind of, to my point, it's sort of a more direct port of Node.js to the Java world. That's not strictly true, but it's kind of, I'm sure they wouldn't like that characterization, but that's what I wrote. So it's very high performance. Again, if you look at the tech and power benchmarks on there, usually in like the top 5 to 8 for like web frameworks, Vert.x is usually in that thing, like right below the Go and below this like the Rust thing. So there's Rust and C are always the top for, yeah, that I get makes sense. But then usually like just below Go, you got Vert.x popping up there in Java land. So Vert.x is a pretty cool library. As I said, it's more like a Node.js port, but it also kind of gives you things that Node doesn't, like it gives you some stuff to handle local concurrency, but also distributed systems. And the nice thing is that the distributed stuff's transparent to you. You don't have to think about it very much. You just kind of write like one function, and you're pretty much got free distribution. Not quite as cool as Erlang, but roughly analogous to Akka, though I probably shouldn't say that given tomorrow's keynote speaker. But so the core unit of concurrency is called a vertical, spelled wrong. And you have the standard vertical, which is a blocking, and you got the worker, which is non-blocking. That matters less now because of the virtual thread. This is sort of a vestige from older Java, because now you can have the executor be a virtual thread executor. And you deploy it with the deploy vertical function. So like Node.js, you have an event loop that just is you can have it single or multi-threaded in the process there. It just does async task execution with blocking or non-blocking I/O. It's based. It's sort of a wrapper around Netty, which is Netty is also sort of an NIO based framework / web server on there, and it's pretty good because it's got some little clever tricks to minimize context switching, and it's pretty fast. So like one of the core primitives there is called the event bus. The event bus is exactly what it sounds like. It's a bus in which you put events, and you can put pretty much any kind of event you want. Usually it's just kind of sort of message passing. You can do a pub sub. You can have just one message the other directly, and you can have like one consumer work queue type thing, and you can do. So I sort of pigeonhole it. You can also just avoid. If you're doing local concurrency, you can actually avoid any kind of serialization at all. You can just have it pass the pointer around. But if you're doing distributed, you need to do like JSON. You need to have some sort of like Serde encoding thing. So the core guts of it is the future type, which matters less now because Java has decent futures, but for a while they didn't. But they're sadly not compatible with each other. But you have a future and a promise type, which is you can have a little placeholder for the result and promise. Everyone here knows what futures are. They're roughly analogous to a sort of a monad there, or I guess a functor. And so you have sort of the context is, again, what it sounds like. You sort of have a wrapper context around given things to play with, and you can avoid using this. You can kind of avoid sharing state at all, and avoiding sharing state makes concurrency. I don't know the exact number. I think 10 million times easier, somewhere around there. So and you don't get paged at 4 in to fix iTunes. So yeah, and buffers are buffers. I don't know why I did a slide for that. That was a waste of everyone's time. But and it comes with a built-in web client, an HTTP client, and also an HTTP server, which I didn't write. But yeah, so you have this nice little built-in. So again, it's sort of Node.js style. You have sort of an entire religion around concurrency that you implement in Java there, and it's good. It's really good. It's you should use it. So and also yes, you have timers as well, which is actually great because these don't block. You can return. You can either do a callback thing, or you can return a future. Either one works there, and these work as you think they work. In this case, it delays 500 milliseconds. It's not exactly 500 milliseconds. It'll be at least 500 milliseconds on there. It gets scheduled, so it won't execute until 500 milliseconds has passed. And you have shared data. So if you do need shared state, it has nice little things to work with. Don't do that if you can, but sometimes you have to, like a counters or a lock or something. Then you kind of have to play with shared state, and so you just do. So, and also one thing, this audience probably already knows about this, but something I've always had to explain to people when I talk about this is back pressure. So the only good thing about blocking I/O is, well, there's two good things. One's predictable and slow. The other thing is that you get back pressure for free because basically you can only push things so quickly. So you get the back pressure in the form of just being slow. So, and that works in a sort of, in a sense. The problem with async stuff when you is that since it's not running right away, it's scheduled. There's no limit to basically how many things you can schedule. So then what can happen is the GC can't figure out, it can't free until it actually executes. So if you don't have back pressure, you can just keep scheduling a million jobs. You run out of memory, it crashes, and then you get yelled at. So you need some way of basically telling it to telling Vert.x to slow down. So there's actually ways of pushing back. Having Vert.x like actively send a signal back to the producer to slow down in the process there, which kind of gives you the tools that you would need for some kind of a back pressure mechanism. And yeah, so I think I'm running low on time, so I got to be a bit quick here. So deploying a vertical, we don't need to go to the main code. So this is the vertical, as I said, the primitive unit of concurrency in Vert.x. And so deploying it locally is that. And deploying it distributed is that. That's it. You literally do nothing else. That is all you do to get distributed programming there. You need to have it in Ignite or a Redis server as well. But otherwise, that's it. You get the distribution for free. So another thing that makes life a little bit easier is RxJava. I think people have given talks on RxJava here before. I should have looked that up. But basically, RxJava is a reactive framework from Microsoft. So forgive it for that. But it gives you nice little functional programming patterns for reactive stuff. So like mouse events or network streams or pretty much anything that kind of just keeps sending events there. So it's kind of based on the observer pattern. It gives you nice little maps and filter and stuff to use on observable there. Again, I'm going to read this to you. You guys, you always are smart. So, and you create it with that. So you can see you subscribe to like events from like, say, a mouse or something like that. There's actually a pretty good blog post called Your Mouse is a Database that talks about kind of the high level how this works here. So it gives everything's async, which you can probably tell I prefer. It gives you a nice composition. You got back pressure. You got error handling. It's pretty and nice, and it works for pretty much anything that sends events. So you can kind of go around and do anything here. Another one you might want to look at is called LMAX Disruptor. LMAX is a trading company based in the UK. And that would usually upset me, but they give me a library, so I forgive them for that. It's way faster than a queue. So I said blocking queues before, and those are useful, but LMAX Disruptor is sort of its own category of queue. It can give you they have done everything they can to minimize like context switches and latency to a point where you can have it, instead of using like a thread yield, you have it just spin. So an old school like style, what you read in your intro to concurrency book, a spin lock, because while that's horrible, it also avoids a context switch, which will reduce latency. So there's like tons of configuration on there, and it uses a ring buffer, so it's fixed memory. You don't have to worry about GC ever actuating because of this, because the memory is pre-allocated and it just overwrites stuff. But it gives you a nice functional interface on top of that, so you just forgive the implementation of it. And you can avoid, there's just basically no locks anywhere in there. So, and you can probably tell I'm not a big fan of locks. So you can use it for it's used a lot in trading. Telemetry is a big thing. I used it for processing biomedical data stuff there. And just as on this laptop, I got about 25 million messages per second on there, which is, I think, pretty good. Compared blocking queue, I got about with some optimization, I got blocking queues down to about 5 million per second on this laptop. Different hardware will have different results, obviously, but on this ThinkPad with an AMD CPU, that's what I got. Sorry I ran out of room here, so I had to kind of get rid of the spaces. But basically, you make a disruptor. It's fixed size of 1024. It has to use an exponent of 2 for that, because it uses bit masking instead of using instead of just using a modulus, again, to minimize latency. And it's just a queue you send events to. So conclusion: Java 21 isn't that bad. Java 11 isn't that bad if you use the new features. It's much easier to convince your employers to use new features of Java than it is to try to get them to use a better language. So accept defeat, at least I did. I've decided that there are certain battles worth fighting. This isn't one of them. Just convince your employers to upgrade instead of a whole rewrite. You probably win that battle. And if you use Vert.x and Disruptor and RxJava, your life will be a lot simpler. I don't really do social media because it was taking up all my time. So I have an email if you want to email me, and I have a blog that I occasionally update. I have a whole bunch of JMH benchmarks I wrote to prove my points about performance on here. So if you guys don't believe me, you can copy the benchmarks and run them. Yeah, that's pretty much it.
Okay, we have plenty of time for some questions.
We pass you the microphone. This.
Hi. Thanks for the talk. I'm in a similar situation, but I get to use Kotlin, so...
Oh, well, fair enough.
Yeah. Kotlin is less ugly.
Yeah. No,
It has the same thing.
as I said, it's not that I have anything against Kotlin. It just never felt sufficiently better for me to like try to convince an employer. Like it's like 20% less code and then a whole rewrite versus, just telling them to upgrade.
Yeah. Okay. So my question here is that did they fix generics already, or is it still hard?
No, they're still kind of horrible. So, yeah, I wish I could give that apology. Yeah, I can't. So, that's what it is.
Thank you.
Hi, I have a question. What should one do when you have, because you said like that you annoy your coworkers, is there a way you think that you can, how should you try to sell to the people who have been indoctrinated? For example, I have a problem that the people have been indoctrinated at my university about Java and they do not want to learn anything else.
Yeah.
And I'm wondering how should
I find that just numbers are pretty good to speak. So that's why I learned how to use JMH. So if I can show something performs better with like fewer lines of code or something to that effect, people tend to be a bit more receptive to that. They shouldn't, because hardware is super cheap and good nowadays. You really don't need that much performance for most stuff. However, people are, me included, are very stupid and will just see a number be smaller, and therefore that's what they do. So, I recommend playing with JMH to see if you can get them to Java micro benchmarking. I don't remember the H what it stands for, but play with that if you can get some numbers that are a bit convincing, and just also show examples. That's all I had to do there. So,
yeah, well, we'll see. Thank you.
Yep.
Hi, hello, thank you very much for the talk. It's very nice, and I'm glad that you have improved your situation over the time. Congratulations. I wanted to rely a little bit more on the comparison you were making before about when you say that people are having to choose between, say, a few hundred, say 1 million or so on for changing language, rebuild from language versus maintenance, which is a bit of the code. Now, I'm taking on that you are assuming that the new language will not have that maintenance cost.
I'm not assuming that per se. That's like so prior to like Java 21, like there's like certain concurrency tools you had like enclosure that were much simpler than what you had in Java. So like core enclosure has core.async, which is wonderful. I have no negative things to say about it. It's and so I felt like there's some code that could be better written using sort of the CSP model that you get with that versus Java. Yeah, you'd still have maintenance costs, and but maybe I didn't answer your question.
Well, I couldn't avoid noticing that you are on that slide you were making the say of saying they spend money on maintenance, a lot more money on maintenance versus spending what will be less money on, let's say, an order of magnitude less money on a rewrite, scratch in a new language. But that is somehow assuming, I see the weakness there is that's assuming that the new language will not have the maintenance, which is, I want to believe that, I believe that.
I conjecture it'll be less. I don't know. I conjecture that the sum total, I don't have numbers on this, but I conjecture the sum total of dollars spent if you rewrote it in a good language would probably be lower than if you just try to keep applying patches, especially people who don't learn how to use concurrency correctly, which most Java engineers don't.
What does maintenance mean?
Well, maintenance
code doesn't rot. Most of the times when people say maintenance, what they truly mean is new features.
New features and also not being paged at 4 in the morning. Maintenance in the more literal translation of the word, which is things breaking down. And so I would argue that having concurrency models that are easier to reason about, have mathematical backing instead of just chaos, tend to be easier to maintain. And I conjecture, again, I don't have numbers on this, I conjecture that the total number of dollars spent would be lower if you rewrote in a good language instead of trying to monkey patch Java all the time.
Okay. How will you prove that conjecture?
That would probably require a study that I don't have funding to do, but that probably require a study like people who have done the rewrite versus not, and then like total maintenance cost of dollars that they would at least declare that they've spent and go from there. And it might not be that, but also, I mean, enjoying yourself is worth something too. That's much harder to quantify. So
Not to your employer, sadly. Not.
yeah, no, employers are evil, and I think some managers get off on the idea that we all kind of hate ourselves. So
That's the question. So
if you just yell, I can probably repeat it. Yeah, me too.
So my question is in the direction of this at night, they are the files of
Yeah.
this man. Now, I would like to, we just said we already like place where like what
Yes.
so what would you give out the file for this by please? It's what you like Java 1.6.
Yes, I would not give up the fight. So to answer your question, because the microphone was out, kind of, I'm guessing, where do I draw the line of like when I fight and when I don't? So like if it's Java 1.6, that's geriatric and terrible. That I would probably not. I'm not sure I'd take a job doing 1.6, to be brutally honest. But if I had to take a job doing 1.6, I would probably, I'd probably say Oracle doesn't support that anymore, so your security bugs are gonna come and destroy your life. But also, yeah, that would probably be something. The upgrade is a fight I'm much more willing to have because I'm much more likely to win. If I try to sit there and tell them to use to rewrite it in Clojure or Scala, I'm afraid I'm unlikely to win that fight. So, and I've become this jaded, cynical old man, and I don't. And I've just decided you need to pick your battles in fights so you actually have a chance of winning. And so, and in the case of the company there, they hadn't upgraded when I joined. Me and one other battle warrior basically kept cajoling management to say we need to upgrade, and eventually they just to shut us up. they let us go into the higher Java language, the LTS, latest LCS that they supported.
So,
Okay, we have the next section in about 5 minutes.
Okay.
thank you.
Thanks for the 5.